Today in this session, we are going to discuss about matrices and arrays and their some uses. Before starting, I would like to share my screen, and I hope the screen is visible to all of you. And I have already prepared all the content which I need to present here. Okay, and this session will be very useful because many things depends upon matrices operation as well as array operations, and all these will help you in the coming sessions and in the numerical methods for data science and many more. These and even if you someone is working on image processing, uh, there also these operations are very useful and helpful for each type of computing and advanced work in your domain. As well, these are also important because MATLAB completely depends upon matrix laboratory, and all the content when we import in the MATLAB are in the form of matrix, and naturally all the operations will depend upon the basic operations and types of matrices. So all matrices play a very important role in MATLAB. Okay, so some are already familiar with you because we use some examples of matrices during the previous lecture as well as arrays. But here we have some new examples, some new types, etc. And all these will help you to write and to manipulate, to access the element, and many more. So we are going to start one by one. Okay. So here is a CLC. As you know, CLC is used to clear the command window, and clear is used to delete the variables and their values from the workspace. Enter. Okay. And CLC. So we are going to start from this script file, and after this session, this script file will be uploaded for your work. So some operations are very familiar. This is the example to write matrix, or how we can create matrices in the MATLAB and syntax. So you can start by using like in this way. You can choose here either 1, 2, 3, 4, and then semicolon. When you will use a semicolon, then the next row will start 2, 3, 4, 5. Okay, and when you will enter, you will see that this is 2 by 4 order matrix. The another way to write the matrix is you can see in the at this place also. Okay, and what is in this matrix? We are not using comma. Okay, you need to use any only space. Either you will use comma between these two elements, or you will use space. Okay, one step space you will use, and in this way also you can enter or you can create the matrix. Okay, so there are two ways to create. Either you will use comma, or either you will use space. So here we are starting by using two matrix and having the same size, matrix A, and then we have matrix B, and the display are used for the same as we use these functions in the previous sessions. And from this place, run section, and this section will be executed when you will when your cursor is in this section by pressing this icon. Okay, so we have these two matrices. First one is A and second one is B. Then after in the second section we have addition of the matrices. We have C is equal to A plus B, and this is used for the display. This is also used for the display of the string. Okay, when you will execute, so in the first line we have the name of the operation, and in the next line we have the display of the result. Okay, and which is stored in C. So on the right hand side we have the operation, and equal is used for assignment, and the information will be stored in C, and at this place this will be displayed. Okay, so matrix addition A plus B is equal to this one. Similarly, we have the operation for subtraction, and nothing new, just only we have the minus sign. Okay, And in the next, we have multiplication. Okay, but I think you are very familiar about matrix of product, a product of two matrices or multiplication of matrices, and element wise element product. In that case, we are using at the place dot. But here we need to multiply two matrices. In that case, you will use only this product sign. Okay, and this will return the value. Okay, thank you. So all of you are muted. If you have any question, you will raise your hand. I will permit you to unmute your mic. Okay, so this will return the matrix multiplication of at this place by using this product. We have matrix A and matrix B already, and these are stored at this place. Whenever you need, you can use anywhere unless you not clear this variable. Okay, otherwise, if you will clear the variable or delete the variable from the workspace, then you have to create again at this place in this section. And when you will execute, we have the product of these two matrices. And scalar multiplication, also very simple. You can see here we are choosing scalar, and f is equal to, we have this operation scalar product A, and all the elements of A will be multiplied with the 2. And this is the operation which will be displayed, and at this place in the next line we have the result of this operation, and you can execute. I think today I will take very less time to create this content. I need 3 to 4 hours, but in the presentation it will take very less time because all these things are very simple. Just you need to understand the syntax and how we can are using. Okay, so transposition, for the transposition or transpose of matrix, we are using a dash. This sign is used for the transpose of a matrix, and yesterday also we present one example. Okay, here in the first we have the matrix A will be presented, and in the next we have the transpose of a matrix. And when you will execute, and you can see that this is the matrix A and its transpose is this one. So first row is here, first column, second row is second column, third row is third column. So the entire matrix A is transpose in this position. Then after we have matrix inversion. Okay, and inverse matrix will exist only if we have determinant not equal to 0. Okay, and you can see for that we are applying here condition. See, if we are using here conditional statement also. If determinant of A not equal to 0, okay, if this you can see here, you can see yesterday we discussed some logical operations, okay, and conditional statements we will discuss in the coming sessions. But here we are using logical operation also. The determinant A not equal to 0, if determinant of A not equal to 0, and if this condition is satisfied, only then this condition will be executed. Okay, so we are telling the MATLAB to execute the sequence of statement according to our desire. Okay, in that case, while writing the program, which statement must be executed and which must not be executed, we need conditional statement, we need logical operations, okay, and relational operations which we discussed yesterday, and all these are very useful. So here once again, if this condition is justified, only then we have inverse of A, and this is statement which is inbuilt function in the MATLAB to find out inverse matrix of any which is a square matrix. Okay, and also this will display, we are using display matrix inversion, and then display the value of this inverse matrix. If this condition is not justified, then in the other case this result will be shown while writing while executing this program. So this is very simple program to understand, and why the logical and relational operator are important, and conditional statement. Okay, these also will be discussed in the coming session in very detail, but here we are using if condition, if else. Okay, and when you will execute, When you will execute from this place. This is complete. Yes, and end. Okay. If then end at this place, this condition is close. Okay. Yes, you can see this is the matrix, inverse matrix. But here you can see one warning. Matrix is close to singular. Matrix is close to singular, but not singular, but very close to singular. That's why we have this warning. Okay, but this is inversion, matrix inversion. You can choose some more examples of any order, 2 by 2 order, 3 by 3 order, 4 by 4 order, by taking some your own examples. You can manipulate easily. Just you need to replace this a matrix. You need to choose according your choice. Okay, if I make some changes, I choose at place 3, and here is 2, and here is 1. Okay, I make some changes, and again I need to update the values. Okay, this is a matrix, and then we have you need to come directly at this place. Yeah, just 1 minute. Transpose, then we have inversion. Okay, because we need to update the values, only then this will execute. Yes, now you can see there is no error message. Okay, so this is the inverse matrix of this one. This is the A matrix. Sorry, this is, I think, B matrix. Okay, yes, this one is the A matrix. So inverse of this A matrix we have is this value. And if you want to display the value A also, you can do at a space. You can display here. Okay, display A. Okay, now matrix A and its inverse both will be in your command window. So you can see here now. You can see this is A matrix. Sorry, yeah, this is A matrix and this is inverse. But I have to write. This is also one important part. How you are managing your statements. Okay, this statement must be at this place. Okay, copy and paste here matrix A. This is matrix A, then display matrix A, then we are going to display matrix inversion. This is the statement. Yes, now you can see again. Yeah, yes, you can see this is the matrix A, and matrix inversion or matrix of A we have at this place. Okay, so you need to manage the sequence of statement, which order you need to do, have the output values or the results. So the sequence of the statement, input statement, sequence play very important role. Yes, next we have very simple example, element wise multiplication. Okay, so this will when you need multiplication, element wise multiplication. Okay, then you will use at this place dot product, and you can, we have already discussed in the last lecture, but here we include this example because this is one special lecture on matrices and arrays. So here you can see one more example, matrix division. Okay, and here also we are going to apply the same condition, and you can check it. If the determinant of B is not equal to 0, then you will find its inverse if this condition is justified. Okay, and then you will multiply this A matrix with this inverse, and we are going to display at its place. If this condition is not justified, then this statement will be executed. And when you will execute this sequence of statement, and when you will run, and you can see that B is singular, cannot be inverted. Okay, so now what happened? The determinant of B is not equal to 0. You can check at this place determinant of B. Okay, you can check here determinant of B in the command window. When you will enter at this place, this is equal to 0. Okay, that's why we are not able to find out inverse matrix of B. So this statement, this condition not justified. That's why all these are not executed. If this condition satisfied, only then this sequence of statement will be executed. Otherwise, this condition, this statement will be executed as you can saw in this example. Okay. Yes, you can see matrix B is singular and cannot be inverted. Got it? Okay. And by using matrix, we can solve a system of linear equations with the help of MATLAB. And there are two methods. One is using line swallow function. Okay. And second we have is backslash operator. So one of them you can use, and we have these. I choose here very simple two equations involving two variable. We have a 2x minus y is equal to 5 and 3x plus 4y is equal to 14. So first we need to convert these two equations in matrix form. Okay, so here we have A is equal to this matrix. These are the coefficient of x and y from the first equation. Okay, and these are the second row is the coefficient of xy from the second equation. And B is are the values for 5 and 14. Okay, so we have these two matrices, and now we are using at this place line swallow function. Okay, so x is equal to this is the line swallow. Just you need to pass the argument A comma B matrix, and then when you will execute this statement, this will return the value of x and y, and at this place we are going to display the result. Okay, so solution, the first statement is for solution using in line swallow, and display will return the values of x and y, which is very simple when you will execute from this place. Okay, you can see this is the value of x variable and this is the value of y variable. So in this way you can use for the large or number of system of equations, whether you have 3 variable, 4 variable, 5 variable in the form of linear equation, and this type of operations will help you to solve system of differential equations also. Okay, when we will start some methods to solve the system of differential equations also. Okay, so these operations will help you to understand for better understanding. Now we have the another method. We have backslash operator. Okay, by using this one you can also solve, and this is very simple. First we need to convert in the matrix A and B, and then you have this statement A backslash B, and by using this very simple statement you will have the value of A and B. Okay, so here when you will execute this section from this place, and you can find we have the same solution. Okay, I think up to this part, there is no question, no doubt, I think. Okay. Now we have, there are some special matrices, and all these also very required while writing the program. Okay. And to find out the solutions, many ways this will help you in numerical methods and the other operation, other scientific computings like image processing and data science and everywhere. Okay, so but all these must be very clear. By zero matrix, zero matrix will have all the elements zero, and you can use zeros function. Okay, zeros, there is inbuilt function in the MATLAB, zeros. By using this one, you can create any order of matrix having all the elements zero. So when you will execute, and you can see this is the matrix of 3 by 4 order. Okay, we are choosing these are the number of rows and these are number of columns. Okay, and once the matrix will include all the elements one, and you can create any order, but here I choose the example of 2 by 2 order. Okay, so this is the one matrix and each element will be 1. So just you need to remember the functions how you can pass the argument and how you can create the matrix. Okay, very simple functions are there. Then you can create identity matrix. And to create the identity matrix, okay, we have I function. By using I function, just this will be the order of the matrix. If you are using 3 at its place, this will create a 3 by 3 order identity matrix. Okay, and when you will execute this action, you can see and check here, you have the corresponding matrix of 3 by 3 order identity matrix. And similarly, we have diagonal matrix. And to create diagonal matrix, if you have diagonal 1, 2, 3, okay, these are the diagonal element. And when you will execute C, yes, we have the diagonal matrix. Just you need to pass the diagonal element. But this is the syntax. This is the syntax. And by using this syntax, you can create your own diagonal matrix. Okay, then we have a random matrix. When you will create the random matrix of any order, the values lies between 0 and 1 randomly. Okay, so this also sometimes required to use. And here is this is the function random rand 2 by 3. This will generate 2 by 3 order random matrix. You can check it by executing. And most important thing is that each time this element will new, you can run again. Now these are new element. The elements are changing, but the values always lies between 0 and 1. Each time we have new values randomly. Okay. Then we have Hilbert matrix. And you can generate, this is the inbuilt function in MATLAB. Help, this function will be used to generate any order Hilbert matrix. But here we are choosing 4. So this will generate 4 by 4 order Hilbert matrix. When you will run, this is the Hilbert matrix. Okay. And this will be fixed value, constant. These are not changing. Again, you will run, you can check it. If you want to generate of third order, okay, then you can have 3 by 3 order. You can choose any order depend upon your choice. Okay. Now we have sparse matrix. Okay, sparse matrix. What are the application of sparse matrix? Anyone can let me know. We have studied, but I never use a sparse matrix. And what are the application where we can use? Anyone can explain me about the application of this sparse matrix? Anyone, please? Can you please let me know the application of a sparse matrix? Anyone? Komal, please unmute your mic and then explain for me. Komal, you can unmute. You are saying something by texting, but if you can unmute your mic, then it will be better. Okay, yes, you are allowed to unmute your mic.
Since it has a lot of zeros in the matrix, it is called sparse matrix, right? Then the reason of these zeros is the noise of guess so. The result has a noise of
What are the application where we use this sparse matrix?
to reduce the noise to get the fine results.
Okay, for example?
For example, in image denoising.
Okay. I got it now. I got it.
Yes, sir.
Anyone can if explain more in detail? Okay, I need to permit you to unmute your mic. Just 1 minute. Yes, now, yes, you can unmute your mic. Anyone can unmute your mic.
Sir, good evening.
Hello, sir. How are you? Good
Fine,
evening.
sir. Actually, sparse matrix can be used in partial differential equation. Using finite element method, we can solve it. I have only that idea, but apart from that computer-based idea application, I don't know. But in finite element method or finite volume method, we use sparse. I mean, directly we do not use sparse matrix, but in partial differential equation, it is very difficult because it depends on more independent variables. So sometimes we use sparse matrix to convert that problem to tridiagonal matrix.
Yeah, yes. In the partial differential equation, right?
Yes.
Yeah, I was also while using then in one problem I use sparse matrix, but now I forget about what is sparse matrix and what are the application. Just now discussing with you, I came to know little bit, but uh, not exactly. Okay, so the thing is, we have various type of matrices, and while using, we must have solid or sound background. What are the purpose of this type of matrices, and why we are using, why these are required? Okay, so application part is also very important while studying all these type of matrices. Okay, so thank you, to increase my knowledge also, Komal and yeah,
Dr. Something else.
Doctor.
Nitin.
Sir, please change your ID.
Yeah, I always forgetting when
Create
I joined.
confusion.
Yeah.
If your name start with Doctor,
I could not able to rename
Sachin
it, sir.
Pandey.
Before
Yes.
joining, I could rename it.
Yes. And now you can rename this ID just now, and you must fix it. Okay. So
Oh,
this will
okay.
help you. This will help me to recognize who is speaking with me. Yes,
Yes.
thank you. So thank you to share your knowledge with me, and we should exchange our thoughts also. Okay, thank you. So once again, I'm going to share my screen. Yes. So when we will execute this section and see what happened as we discuss. We go to some information from yeah, a sparse matrix. We have in the first column all the elements are 0, and the rest are 4, 5, 6. These you can see this is a sparse matrix. But why the first column is all the elements are 0? We need some more information about the sparse matrix. We have to go through, and then we will able to understand why this appear in this way. Okay, and also there will be some ways to reduce any matrix in the sparse matrix. I'm right. I myself also did not read more about sparse matrix. Okay, so now we have how we can access element of the matrices, and this is also very quite simple. Yeah, here you can see we have this matrix of 3 by 3 order, and if you want to access any element, okay, here we want to access one element from A, from second row and third column, and this element will be displayed in the command window. So this is the single element. Okay, this is the single element. When you will execute, and you can see in the command window, we have this is the matrix A. Okay, and we access the element from the second row and third column, this element, and single element has been displayed at this place. Okay, if you want to extract any element from the matrix, then you will use in this way. You can change if here is 3 and here is 2. Okay, then again we have this element. So this is the third column, this is the third column, and third row and second column. We have 8. Then we have accessing row or column. Sometimes we need to access any row or any column when you have a large data in the form of matrix, and you will import in MATLAB. But the thing is, when you want some statistical analysis, okay, in that case, you have to assign the variables because if the database have a large number of rows and columns, but only 2 or 3 parameters are required for your purpose. In that case, you need to extract only a row, that particular row and column. Okay, so these operations will help you for the assignment of the variables which are either row or column from the database. Okay, because all the database which is in the form of Excel is itself a example of matrix. Okay, so by using this one, this is the second row and entire column. For the entire column, you will use at its place double dot, a colon. When you will use colon, it means the entire all the elements of element column will be accessible. Okay, so see here, and in the next we have also the further example of column. If you want to access complete third column, okay, so see what happened when we will execute So this will access all the complete row, and this will access all the element of column C. Yes. So here we have all the column. Here we have element of all the column from, and we have second row, but all column, whatever we have. Yes. So here you can display also the matrix A. We have matrix A, display A. Now execute. Yes. So now you can see this is the A matrix. Okay. And by using this one, we have second row. This is the second row. Okay. And second row, but all the columns. So after space, after comma, we have these are the columns. So when you are not assigning any number and using colon sign, then all the column will be extracted in this way. And for the next one, for the second, when you will use this statement, in this case, sorry, yes. So when you will use this one, in this case, all the rows, but third column. So the entire column, third column will be access. And you can see this is the third column, 369. And by using this statement, we have those element and any entire column by using these operations, and then you can assign. So this column has been stored in this variable. Okay, you can choose here any assignment variable, whatever you need, X, Y, Z. Okay, so from this database, we have only one column. And by using this one, we have only one row. Now we have, if you want to access sub matrix. Okay, so here see for the sub matrix, but we have the matrix is very small, matrix 3 by 3 order. Okay, so what is the meaning of this one? First to second row. The meaning of this one is first to second row, and the meaning of this one is second column to third column. Okay, so this is the submatrix, and see after running in the yes. So these are the submatrix. Okay, so the element are chosen from these are first row and second row, means these two rows. Okay, and columns are second and third. So second and third. So the element submatrix from this matrix will be 2, 3, 5, 6. Compare this element with this matrix. And also modifying element. If we sometimes you need to modify the matrix or any element of the matrix, you can do. See here, we have the matrix A, which is this one. But we want to replace the element from third row and second column. Date must be equal to 10. Okay. And we are assigning at this place 10 for the element, this one. And this element is from third row and second column means this one, 8. So now 8 will be replaced by 10. See, by running the code, and you can see in the matrix only this element has been replaced. Okay, so in this way you can replace the element from the matrix. So this is all about matrix operations. Okay, and now we have arrays. So some of the examples we have already discussed, but some are new. You can see, okay. So arrays in MATLAB are fundamental data structure that allows you to store and manipulate data. MATLAB supports various types of arrays such as vector, matrices, and multi-dimensional arrays. So here are some examples which I choose for you. Okay, here is how you can create array. Okay, so this is very simple example. V is equal to, in the square bracket, 1, 2, 3, 4, 5, and when you will execute, this will display this this array. Okay, and if you have two-dimensional means we have matrix. Okay, matrix is two-dimensional array, and you already familiar about this array. Then we have a multi-dimensional array. Okay, here is we have 3, 4, 2. I did not check about this one. Highly used for data science, but I am not working in data science. Okay, we can check it by displaying, but here the elements are random. Okay, random numbers from a standard normal distribution. Okay, so when you will execute, we can have the example of this type. Yes, you can see this one is first one. Okay, 3 by 3 order, and then we have the second one. Okay, we have 3 by 4 by 2. So this is first one 3 by 4, and this is second one 3 by 4, and all these are randomly from the normal standard normal distribution. So in this way we can generate 3 by 4 by 2. You can see the example of in the image processing. When you will import any image in the MATLAB, that is also of this type. Okay, so there are red, green, and blue. Three colors are there. So there will be three layers. So what will be there when you will import any image in the MATLAB? This will be some order of the matrix, but here at this place we have three. At this place we have three. There will be three matrices. One for red, second will be for green, third will be for blue. Okay, and you can check for this one also. Yes, you can see. So when you will import any image in the MATLAB, that will be just like a number you can see at its place in the form of matrix. So one will be for red one first will be for matrix for red color, and the second will be for matrix for green color, and third will be for blue. Okay, so in this way you can generate, you can have the examples. Can we check for a higher order? I don't know, but we can try. Yes, you can create any order. Okay, here we are choosing multi-dimensional array. So yeah, this is up to 5. You can generate in this way. Then after access element, okay, we have A is equal to, by using this one, you can access the third element of the vector. Okay, we can access the third element of the vector. And if you want to access any element of the matrix, then we can access by using this one. But in the case of vector, you can use this one. You can execute, and you can see, yes, this is the vector V. Okay, and its third element is 3. And in the case of matrix, we have already discussed. One more thing, index of vector in MATLAB start from 1. But if you are using Python, the indexing in Python start from 0. Okay, so in Python, the meaning of this one will be, if you want to access third element, then you have to use at the place 4, because index, sorry, if you want to access third element, then you have to use 2 at the place of 3 in Python, because the indexing in the Python start from 0, 0, 1, 2, 3, 4, 5, and so on. But in MATLAB, it start from 1. Okay, these are some same operations as we discussed. Element-wise multiplication is there. Then we have matrix multiplication when you will multiply two array. Okay, element-wise multiplication in array and matrices. Both we have dot. And for the matrix multiplication, we are using this one. And function for arrays. Okay, some part is missing. If you want to find the size of array, okay, then you will use size at this place. You can execute. Yes. So this is the matrix A, and size, this is the size. By using size function, you can create. So up to all the things are very clear to all of you. If you have more question, you can feel free to ask. Maridula Jain, yes, you can unmute your mic.
Sir, if we use one suffix only, like in three-dimension array, if we use B3 only, means if we are not using all the three suffix, then which element, is it syntax error or we will get any element?
I don't get your exact question.
If we are not using all the suffix, exactly B is 3-dimensional array. We had created, हमने B जो बनाया है 3-dimensional बनाया है 3,4,2 करके random.
Yes.
So अगर मैं एक ही सफिक्स काम में लूं केवल, जैसे पीछे 2 या 3 सफिक्स लिखने के बजाय केवल एक ही सफिक्स B और ब्रैकेट में only 3 लिखूं या only 10 लिखूं, तो कौन सा एलिमेंट मिलेगा हमें?
Okay, just 1 minute. I am again sharing my screen. Come to this place. This one.
Yes sir.
We were at this place, right? Okay.
Yes.
And we have this vector.
No, B random 3-dimensional array, multi-dimensional.
B.
हाँ, I am talking about B random जो
B.
हमने yes,
Okay,
yes.
okay.
So exactly मतलब ये एरर तो नहीं दे रहा है, ये एक एलिमेंट दे रहा है. अब वो कौन सा एलिमेंट दे रहा है वो मैं जानना चाह रही थी. मतलब इसका क्या मेथड है, ये किस हिसाब से एक्सेस करता है? मतलब 1
इसमें से?
सफिक्स पे भी एलिमेंट मिलता है, 2 पे भी मिलता है और 3 पे भी मिलता है.
इसमें से?
हाँ, इफ आई एम राइटिंग B ब्रैकेट में मींस एनी नंबर, तो वो एक एलिमेंट देता है. तो वो कौन सा एलिमेंट देता है मींस
Just
एग्जैक्टली?
1 minute. I am executing this statement. Okay, then we have this one. Okay, this is a random array. And
Yes
all
sir.
the values lies between, in this case, this is completely depends upon standard normal distribution. Okay.
Yes sir.
Yeah, and all these elements are randomly.
Yes sir.
Okay. Now let me know your question. What you want? What do you want from this matrix?
सर सफिक्स अगर हम पूरी नहीं लगाते हैं, जैसे 3 अगर हम लगाते हैं 3,4,2 या कोई भी 3,1,1, तो एक एलिमेंट हमें मिल जाएगा जो भी वो लोकेशन का है. बट अगर हम सफिक्स कम लगाते हैं उसके बाद भी हमें एलिमेंट मिलता है, तो वो कौन सा एलिमेंट किस थ्योरी के हिसाब से वो देता है?
Okay. Presently, I don't know, but you send me your question. I will try to get the exact answer. Only then I will reply. But right now, I don't know.
ओके सर.
Yeah, I don't know how this one, but you send me your question. I will try to find out the exact answer. Okay, only then I can justify you. Otherwise, I am not able to justify your question. Okay, but just we have the some examples how you can create. Okay, but your question is different. Must be known, but presently I don't know.
सर एग्जैक्टली 2-डायमेंशनल एरे में भी अगर हम 1 सफिक्स देते हैं तब भी हमें एलिमेंट मिलता है. तो ये किसी मतलब हर एलिमेंट को कोई एक नंबर दे रखा है फिक्स, तो वो वर्टिकल है या हॉरिजॉन्टल है, किस हिसाब से है?
Okay, I will give you this answer in the coming session.
ओके सर.
Okay, thank you. So if you want to access, then you can do in this way. Okay, your name please. Maridula Jain.
या हाँ, मृदुला जैन.
Maridula Jain. You are from Jaipur?
यस सर.
NIT?
नो, सुबोध ऑटोनोमस कॉलेज,
Okay.
डिग्री कॉलेज.
Thank you, ma'am, for your nice question.
ओके.
Yes. This will also increase my knowledge. I will try to find out the exact answer now, but it will take time. Okay. So a matrix product, and then we have function of array. One is size. Okay. So by using size, we can get the size of the array. Okay. Just 1 minute. I am sharing my MATLAB and then sharing again. Okay. So we use at its place size function, and this will return the size of the matrix A. Okay, you got it. So some part was missing at this place. There are some more functions I want to let you know. And for the vector, there is a length function. For the vector, there is length function. For array, for the array, we have length function. Okay, and we have v vector. When you will execute, this will return the size, length. Okay, we have used already. Cursor and then run. Control S, run the section. What happened? Okay, display, and then execute. We have 5. So sometimes when we have any array or you have large database and you want to check how elements are there, then you will use this length function. And sometimes if you want to write any program for mean, median, mode, standard deviation. Okay, and you have numerous arrays, but we need to count how many elements are there. So each time we are not able to count. Just you use this one, length of the vector, okay, or length of array. This will return the total number of element of the array. But here in this V, we have 5 element. Okay, you can check V. So these are 5 elements. And next we have reshape. Okay, you can reshape by using the example. A reshape function is also there. Just 1 minute. We have one matrix. We are choosing some different reshape the function. Okay, reshape of matrix A. Okay, so we want to reshape the matrix A. This is the A matrix and 1 by 9. See, execute. Sorry, we have to display also. Display A and then execute. Sorry, this is again, we need F. Yes. So you can see these elements are converted into one-dimensional array. Okay, so in this way you can reshape in any order. But you need to keep in mind the matrix is 3 by 3 order. Okay, so then there are 9 elements. So either you can convert in this direction or you can do 9 or at this place 1. Again check it. Okay, so if you have the element in the matrix are 12, so 3 by 4 order, it means there are 12 element. So you can manage in a different way, like 2 by 6 order, 6 by 2, 1 by 12, 12 by 1. Okay, 4 by 3 and 3 by 4 in any order, but the product must be equal to 3 by 4. So according to that, you can manipulate, you can reshape in any order. So this is the use of reshape function. Got it? You got it? Okay. So this is all about today's session. I will upload this file and including some more examples. After this session, you can find the entire file. If you have more question, please feel free to ask from me.